Look up at the night sky and you'll see stars, countless points of light scattered across the cosmic canvas. Every star is a massive sphere of gas undergoing intense nuclear fusion, some larger than our entire solar system. They are the furnaces where the universe forges its elements. Yet stars are not eternal. They are born, grow, shine, and eventually die, sometimes quietly, other times in cataclysmic explosions. In this video, we'll embark on a journey through the life cycle of stars, uncovering how they shape galaxies, seed planets, and even make the atoms that form our own bodies. Every star's journey begins in the quiet, mysterious depths of space, in a vast, cold cloud of gas and dust called a nebula. These stellar nurseries are scattered throughout galaxies, often glowing with ethereal colors where new stars are being born. Composed mostly of hydrogen, the most abundant and simplest element in the universe, these clouds also contain helium and trace amounts of heavier elements and interstellar dust. At first, the nebula drifts peacefully through space, but over time something disturbs this calm, perhaps the gravitational tug of a nearby star, a collision with another cloud, or the shockwave from a distant supernova. These disturbances create denser regions within the nebula. Gravity, the silent architect of the cosmos, begins its work. The denser clumps begin to collapse under their own weight. As they do, the gas compresses, heats up, and spins, forming a growing sphere called a protostar. This protostar is the embryo of a future star. At this stage, it's not yet fusing atoms in its core, but the immense gravitational pressure generates intense heat. The core can reach several thousand degrees Celsius, glowing dimly in infrared as it continues to contract. Protostars vary greatly in their fate. Some never gain enough mass and remain as brown dwarfs, failed stars. Others continue to accrete material from their surroundings. When the core temperature reaches a staggering 10 million degrees Celsius, a dramatic transformation occurs. Nuclear fusion ignites, and the protostar becomes a true star, marking the beginning of its long life on the cosmic stage. Once nuclear fusion begins in the core, a star officially enters the most stable and longest phase of its life, the main sequence. This is where a star shines steadily, fusing hydrogen into helium and releasing immense energy in the process. In the core, hydrogen atoms are crushed together by gravity, overcoming their mutual repulsion to create helium. This process, nuclear fusion, releases a tremendous amount of energy, which radiates outward as light and heat. The energy creates an outward pressure that balances the inward pull of gravity. This delicate balance is called hydrostatic equilibrium, and it's what keeps the star stable for millions to billions of years. Our own sun is in this phase right now, about halfway through its 10 billion-year lifespan. It has been shining reliably for 4.6 billion years, warming Earth and supporting life. But not all stars are created equal. Their mass determines their personality and destiny. Small stars, known as red dwarfs, burn slowly and dimly, using their fuel so efficiently that they can live for trillions of years, longer than the current age of the universe. Medium-sized stars like our sun shine more brightly and live shorter lives. Massive stars, on the other hand, those with several times the mass of the sun, burn hot, fast, and bright. Their lives are short, lasting only a few million years. Eventually, hydrogen in the core runs out. When it does, the equilibrium breaks. Gravity begins to overpower the dwindling fusion pressure. The core contracts, the outer layers expand, and the next dramatic phase of stellar evolution begins. A star's life ends not with a whimper but with transformation, sometimes gentle, sometimes explosive. When hydrogen in the core runs low, the balance maintaining the star begins to falter. For stars like our sun, the core contracts under gravity, becoming hotter and denser. Hydrogen fusion continues in a shell around the core, and the outer layers expand enormously. The star becomes a red giant, its radius swelling hundreds of times. Mercury, Venus, and perhaps even Earth could be engulfed by our sun in this phase. Inside, the star begins fusing helium into heavier elements like carbon and oxygen. But eventually fusion stops entirely. The outer layers drift off into space, creating a glowing, colorful cloud of gas, a planetary nebula. The remaining core cools into a white dwarf, a dense ember of a star roughly the size of Earth, yet containing half the sun's mass. It no longer shines from fusion, only from residual heat, fading over billions of years into a black dwarf. Massive stars face a more violent fate. As they age, their cores fuse progressively heavier elements, carbon, neon, oxygen, silicon, until they form iron. But iron fusion consumes energy instead of releasing it. With no more fuel to sustain pressure, the core collapses in less than a second. The result is a supernova, a titanic explosion that briefly outshines entire galaxies, blasting enriched matter into space. What remains of the core depends on its mass. If it's between 1.4 and 3 solar masses, it forms a neutron star, an ultra-dense object with the mass of the sun compressed into the size of a city. If even more massive, the core collapses into a black hole, a singularity where gravity becomes so intense that not even light can escape. The death of a star is not the end, it's a new beginning. The gas and dust expelled by dying stars don't vanish. Instead, they enrich the interstellar medium, the space between stars, with heavy elements forged during stellar lifetimes and violent deaths. These materials, carbon, oxygen, nitrogen, iron, are the ingredients for planets, atmospheres, oceans, and even life. When supernova shockwaves sweep through space, they compress nearby clouds, triggering the collapse of new nebulae. From the ashes of old stars, new ones are born. This cycle of stellar birth, life, and death is the engine of cosmic evolution. Every star contributes to the ongoing transformation of galaxies. Our own solar system formed from such recycled material, dust and gas from earlier generations of stars. The calcium in your bones, the oxygen you breathe, the iron in your blood, all were created inside stars that lived and died long before Earth existed. Through this cosmic recycling process, the universe grows richer and more complex over time. Stars are not just lights in the sky, they are the alchemists of existence, cosmic crucibles forging the elements of life, passing them on from one generation to the next. In every way that matters, we are the children of stars. The life cycle of stars explains some of the most important processes in the universe. It's how elements are formed, how energy flows through galaxies, and how the building blocks of life are created. By studying stars, we're not just learning about distant objects in space, we're learning about ourselves. Every atom in your body has been part of a star. Understanding how stars form and die gives us insight into where we came from, and how the universe continues to change. The next time you look up at the night sky, remember, you're not just seeing light, you're seeing history. You're seeing the ongoing cycle that connects all things, from the most distant galaxy to life here on Earth. Thanks for watching. If you enjoyed this video, don't forget to like, comment, and subscribe. There's so much more to explore together. Stay curious, and we'll see you in the next adventure.